Hi, welcome to the Olympiad geometry. Let's continue our study on the 9-point circle. Here is a problem. 3 altitudes in acute triangle ABC are AD, BE, CF. EF parallel line that is through D, intersecting AC and AB on Q and R. Right? This should be R on AB and so AC and AB on R and Q, right? EF intersects BC on P. Prove that midpoint of BC, which I set it as M, is on the circumcircle of triangle PQR, right? So let's connect PQR. Okay. So what is this problem actually asking for? Is that we want to prove point M is on the circumcircle of triangle PQR, which means that we just need to prove MRPQ are cyclic, right? That's the same claim. So we connect QM, we connect MR, right? We just need to prove that MRPQ are cyclic. And for the MRPQ, M is a very easy point that it's just midpoint of BC. For the R and Q, they're from the parallel line of the QR, right? QR is in parallel with EF. So Q and R come from the parallel line to EF, right? And P come from the EF intersecting BC, which means this condition that this problem set QR is in parallel with EF is very critical, right? That's a key point. That's a break point of this problem. So what we can do to prove that 4 points are cyclic? We can just prove angles, right? If we can prove angle MQD equals to angle MQR equals to angle MPR, that means MRPQ are cyclic, right? And how can we prove that? The first thing we need to think about is that how can we get the Q and R? We get Q and R from a parallel line that is through D, right? And what is D? D is the altitude, the foot of the altitude on the edge BC. So it gives us a little bit of inspiration that we need to use a 9-point circle. Why? Because M is the midpoint of BC. D, E, F are foot of altitudes, right? We already know that these 4 points, they are cyclic, right? We already know they are cyclic. So let's see. If we want to prove angle MQD equals to angle MPR, right? If we want to prove these two angles are equal, what we can start from, right? This angle is very difficult to find. This angle is very difficult to find. But what we can find is from the parallel line, right? Because EF is in parallel with QR, so we get that angle FEA equals to angle QRA, right? We just try to mark as much as possible what we can get from the problem set, right? That's how we solve the problem. The angle FEA equals to angle QRE, right? And it equals to angle REP. Right? And remember that in the previous lots of problem, we already proved that this angle, the angle BED equals to angle BEF, right? So it also equals, that means the angle FEA is also equivalent to angle DEC, right? FEA equals to angle DEC as well. Here is H. And angle DEC equals to angle DHC. Right? And equals to angle AHF. And equals to angle ABD. Right, we just put as much as we can. Now we take a look at these equations. So we find that angle DER equals to angle DRE, which means DE equals to DR. Right, DE equals to DR. And we know that E, the point E, is the foot of altitude BE, right, on the edge AC. That's how we get DE, right? And the point R is a parallel line intersecting AC, which means if we look at Q and F, F is also the foot of the foot of the altitude CF on the edge of AB, and Q is also the parallel line intersecting with AB. So what about the DF and the QD? Let's just do the connection here. So the angle AQD equals to, see here, angle AQD equals to angle AFE, right? Due to these two lines are parallel, so AQD equals to AFE. And angle AFE equals to angle AHE, right? Equals to, so angle AFE, I just make, equals to angle AHE equals to angle BHD. And because BDHF are cyclic, so angle BHD equals to angle BFD. Now we see that angle AQD equals to angle BFD, which means DQ equals to DF, right? So that's very interesting. what we get here is that we find the DE equals to DR. DR is an edge in triangle PDR. And we find that DQ equals to DF, where DQ is one edge in the triangle DMQ. Right? If angle MQD equals to angle RPD, and we already know that angle MDQ equals to angle RDP, that means this triangle, the triangle MDQ and triangle RDP are similar, right? Which means that we can try to find the ratio of the edges to prove they are equivalent and they are similar, right? So let's do that. We already have QD equals to QD, right? We already have QD equals to DF. And we also have DR equals to DE, right? If angle MQD equals to angle MPR, then we know that triangle MQD is similar to triangle RPD. Then we know that QD to PD equals to MD to DR, right? That's how we relate this QD and DR together, which means QD times DR equals to PD times MD, right? only if MQD equals to MPR, right? But we can trace this equation all the way back to here, right? If we can prove this, then all of these are valid. That means these two are equal. So look at this one. We have now it becomes that we want to prove QD times DR equals to PD times MD, right? And QD equals to DF, DR equals to DE, which means from here we can get that DF times DE equals to PD times MD, which means see DF and DF is here and times DE, right? So DF divided by PD equals to MD divided by DE, right? DF to PD and MD to DE, which means that we just need to prove these two triangles, the triangle MFD similar to triangle let me see, MFD, right? So EPD, right? We just need to prove this. If we can prove this, then this would be valid. All of these equations are valid, and we can get these two angles to be equal, and then we know that the 4 points are cyclic. So how can we prove this? Look at here, the angle. We want to prove the triangle MFD and the triangle EPD, right? Now we see here, because we already know that angle EDP, which is angle EDC, equals to angle FDB, right? FDM. So we already know this. Angle FDM equals to angle EDP, right? This is one condition we know. And for another one, see here, because FEDM are cyclic, right? The circumcircle of FEDM is a 9-point circle of the triangle ABC, right? They are cyclic. So angle DEP equals to angle FMD. And from these two, we know that triangle MFD does similar to triangle EPD, right? And from this, we know that this ratio is valid. And from this ratio is valid, we already proved this this condition. So these are valid, and all the way back that we know angle MQD equals to angle MPR, which means MRPQ are cyclic. Right. This is a pre-IMO problem. It's actually medium difficulty level problem. It's not a like take you an hour issue. It's just you need to be careful to find the break point, right? For this problem, the break point is actually not that difficult to find, because if you think about what you need to prove, you just need to start looking at these points, right? Where does these points come from? So for the midpoint, it's easy, right? You have triangle ABC, then you have the edge BC, then the midpoint is very straightforward to find. So it basically tells you nothing. But for the other 3 points, PRQ, they all come from the parallel lines, which means that you need to use the parallel lines a lot. And based on that condition, you can just derive all the equivalent of the angles you can find, and then it would be much straightforward. Okay, that's today's problem. I hope you like this one. See you in next one. Thank you.